Welcome to another video tutorial on Easy System Designer. This video uses the example of a traveling drive to show you how to determine the mass and moment of inertia of bodies that are moved in your application. For example, the mass of the vehicle and the additional moments of inertia for wheels and axles. If required, you can call up the auxiliary calculators directly in the respective input field using a button. The mass calculator calculates the mass of the body from its geometric data and the density of the material. Various basic geometric bodies, such as cubes, cuboids, or cylinders, are available for selection. More complex bodies can be assembled from basic bodies. The vehicle in the example consists of a solid steel base plate and an aluminum box. The base plate is represented as a cuboid. Select the unit in the menu and enter the dimensions. You can either enter the density of steel or retrieve it from the database. You can transfer the resulting mass to the table by clicking on the button. For the box, first enter the external dimensions. You can also select the density of aluminum from the database. Transfer the resulting mass of the subbody to the table. For the cavity, then enter the internal dimensions of the box and change the sign. This allows you to determine the weight of the box from the difference between car box and car box hollow. Done! Now you can transfer the mass of the entire vehicle to the application data using the Apply button. You can use the inertia calculator to determine the mass inertia of the vehicle's wheels and axles. The inertia calculator calculates the inertia of the body around its axis of rotation from its geometric data and, optionally, its density or mass. For the axle in the example, use a cylinder as the body and the z-axis as the axis of rotation, as shown in the sketch. Then enter the geometric data. For the second axle, adjust the name and also take over the value to the table. Now you can repeat the process for the four wheels of the vehicle. These are made of hard rubber, and the density can also be found in the table. This gives you the total inertia of the body, which you can transfer to the application data by clicking on the Apply button. The lever arm of rolling friction, which results from the pairing of the wheel and surface materials, is decisive for the traveling resistance. Values for typical material pairings can be found in a table, in this case hard rubber on steel. You can enter further details if required. The values for the diameter of the wheel and the angle of inclination are automatically taken from the surface data of the application. The resulting traveling resistance is displayed, and you can transfer the value to the application data using the Apply button. You can also call up all help calculators and physical value tables independently of an application using the navigation tree. Please take a look at our other videos to get the most out of Easy System Designer.